Hello, welcome back to Learn Physics. In today's video, we are continuing with the motion chapter for class 9. This is the continuation of your revision portion. Okay, so already we finished all the detailed explanation of your syllabus, and now we started the revision. I think you are already aware of that. And if you don't know, if you are watching this video for the first time, the portions related to this video, all the videos I had given in the description box. You can just scroll that down, and a small arrow is there at the rightmost end. You can put that, and then the description box will be popping out, and you can watch those videos. It is there as a playlist itself is given. Okay, so now in today's video, as I said in the last video, I'll be starting the equations of motion. So derivation of this equations of motion and all I had already given, and in last video we discussed about the graphical representation. Okay, so this is about the equations of motion. Okay, after finishing this, so much see till today whatever we explained, we will be doing some of the numericals related to all those things. Okay, today equations of motion and its related numericals. Okay, so there are three equations of motion. Okay, the equations of that are very important, and you should by heart all these three equations and its derivations also. It's very easy. Graphical method only we are adopting, and here in this equation of motion, all the equations are related with the uniform acceleration. Okay, equations of motion. It's under uniform acceleration. So if the object is moving under uniform acceleration, then only we can use this equation of motion. Okay, usually children will be doubtful whether we should use the formula velocity equals distance divided by time, acceleration equals change in velocity by time. Those formulas we already learned. So children will be confusing while reading the question, should we use the equation of motion or the previous formulas. Okay, so in the question, if question comes like the object is under uniform acceleration, you can use equations of motion if it is under uniform acceleration. Okay, uniform acceleration means equations of motion you can apply. Sometimes they won't be saying uniform acceleration and the object is falling down and we are throwing the object upward direction. So acceleration in both the cases, it will be acceleration due to gravity, g. Okay, so that formula you can use there. Okay, understood? When we will be using this equations of motion, if the object is under uniform acceleration, if the car is moving under uniform acceleration, or we are dropping some object, or we are throwing some object, or object is falling down, in those cases we will be using uniform, considering as uniform acceleration, we can use any of the equations of motion. So in equations of motion, the first one is V equals U plus AT. Okay, here V is the final velocity, U is the initial velocity, and V is the final velocity. A is the uniform acceleration, and T is the time. So we know it is uniform acceleration. So this relation is called as, apart from acceleration, velocity is there, time is there. So we will say it is VT relation, or velocity and time relation it is. Velocity and time, V equals U plus AT. Next is S equals UT plus half at square. Displacement is there, time is there. So we can write it as displacement time relation. Okay, next is v square minus u square equals 2as. Here v and u are there and a is there. A no need to consider, apart from a, s is there. So we can say it as displacement velocity relation. Okay, these three are the important equations of motion. V equals u plus at, s is equal to ut plus half at square, v square minus u square equals 2as. Okay, and here while we are using this one, I told you about uniform acceleration. Okay, same way, if we are throwing some object with a velocity, of this much, while they are saying like that, throwing with a velocity means that will be the initial velocity. Okay, so we are throwing. Instead of that, if we are dropping some object, initial velocity will be 0. Okay, dropping means initial velocity is 0. Throwing means initial velocity, how much velocity we are applying. While throwing the object, what will happen? Final velocity we will consider it as 0. Okay, while we are throwing some object, final velocity we will consider as 0, and while we are dropping some object, initial velocity will be considered as 0. Okay, clear? So these are the basic things you need to know about while doing the numerical part. Okay, so here a marble rolling on a smooth floor has an initial velocity of 0.4 meter per second. If the floor offers a retardation of 0.02 meter per second square, calculate the time it will take to come to rest. Okay, marble is rolling on a smooth floor has an initial velocity. So what is the representation of initial velocity? U. It is 0.4 meter per second. If the floor offers a retardation of 0.02 meter per second square, what is this retardation? Negative acceleration. So A equals minus 0.02 meter per second square. Calculate the time it will take to come to rest. It is coming to rest position. So what will be the final velocity? Final velocity equals 0. What we should find out? Time. So including U, A, V and T. Which formula we know? V equals U plus AT. So we can write it as V equals U plus AT, that is 0 equals 0.4 minus 0.02 into T. So therefore T equals 0.4 divided by 0.02. Okay, shall we write down with like this without this negative symbol? Yes, because this negative sign I am taking it to the side. So 0.02 T equals 0.4. Therefore T equals this much. So while we are solving this one, 40 divided by 2, that is equal to 20 seconds. Okay, easy, right? Just understand this, come to rest. Then you should understand that velocity, final velocity is equal to 0. And if it is retardation, acceleration will be negative. Okay, these things you should understand and just apply in the formula. Okay, so next one is a car starts from rest and attains a velocity of 18 km per hour in 2 seconds. Find its acceleration in SI unit. Okay, so a car starts from rest. That means, yes, initial velocity is 0. Initially it was at rest. And attaining a velocity of 18 km per hour. That means final velocity is 18 km per hour. Find its acceleration in 2 seconds. So t is also given as 2 seconds. Find its acceleration in SI unit. So first we should check all the given units are in SI unit. No, there's a kilometer per hour is there. So we should convert that into meter per second. So 80 into 5 by 80. To convert it into meter per second, we should multiply it with the 5 by 18. So how this is coming, that one I already explained in the previous video. That is in the actual playlist it is there. So kilometer to meter conversion into 1000 divided by hour to second conversion multiplying by 3600. So while we are solving that one, we will get it as 5 by 18. So always remember, to convert kilometer per hour to meter per second, we should multiply it with a 5 by 18. So 5 meter per second. So including u, v, t and a, which is the formula? Again, v equals u plus at. So v equals 5, u is 0, a is unknown and t 2. Therefore a equals 5 by 2, that is 2.5 meter per second square. Okay, clear? Understood how we are finding out this one? Next is the brakes applied to a train moving at 90 km per hour produces a retardation of 5 meter per second square. What distance will it cover before coming to stop? Okay, so brakes applied to a train moving at 90 km per hour produces a retardation of 5 meter per second, which was moving at 90 km per hour. So initially it was moving with a velocity of 90 km per hour. So as I told you in the previous one, see all the units better we can convert it into SI unit itself. So it is 90 into 5 by 18. So here 5 5s, that is 25 meter per second. Okay, then produces a retardation, acceleration. Retardation means negative, minus 5 meter per second square. What distance will it cover? So we need to find out the distance before coming to stop. So final velocity is 0. Its stopping means its final velocity is 0. Say u, a, s, v. Including that, which equation is there? V square minus u square equals 2as. So we will get it as v square minus u square equals 2as. V is 0 minus 25 square equals 2 into minus 5 into s. Therefore, s is equal to 25 square, 625. This minus and minus will get cancelled, divided by 10. So we will get it as 62.5 meters. Okay, clear how we are doing this? So these are the all these questions are very easy. We need to remember only these three formulas. And what are the hidden data in that? You should understand. Say if it is coming to stop, or if we are dropping some object, those kind of things, hidden data you should understand. Okay, that is through practice it will come. Okay. So next is, a bus accelerates at 2 meter per second square for 10 seconds. After the start, 10 seconds after the start, and retards at 1 meter per second square for next 10 seconds. Find the total distance covered by the bus. Here initially it is moving, accelerating for 10 seconds at a particular acceleration, and then it is retarding at 1 meter per second square for next 10 seconds. Okay, so how we can find out the total distance covered? So what are the data given in the first case and the second case? So here we can consider it as two cases. So here first one, acceleration is given as 2 meter per second square for first 10 seconds. T equals 10 seconds. So bus accelerates at 10 meter per second square. It is accelerating only. So initially we are considering it as the object was, the bus was at rest and it is acceleration. So it is 0. We need to find out the distance covered. How we can find out the distance? This is the case 1. Okay, distance S is equal to ut plus half at square. U is 0, so it is half into 2 into 10 square. So we will get it as 100 meter. After moving to 100 meter, it is retarding at 1 meter per second square for next 10 seconds. So it was moving at a velocity of at an acceleration of 2 meter per second square. So what before retarding, what was its initial velocity? Initial velocity is given as, so we can find, let's say initial velocity is, what will be the this velocity over here? That will be the initial velocity at this position, isn't it? So here first we need to find out what will be the final velocity here. That will be the initial velocity in case 2. It was moving with an acceleration 2 meter per second square, then it is retarding. So what will be the initial velocity when it was retarding? That will be the final velocity of the first case. So here you should find out the final velocity. V equals u plus at we can apply because u is there, a is there, t is there. V equals u plus at, u is 0, a is 2 into 10. So we are getting it as 20 meter per second. Okay, so here initial velocity will be, we got it as 20 meter per second. The final velocity of the bus in the first case will be the initial velocity of the bus in the second case. Okay, now it is retarding at an acceleration of 1 meter per second square for 10 seconds. Okay, so what will be the distance covered in this case? Ut plus half at square. U is 20 into 10 plus half into a is minus 1, t is 10 square. So we will get it as 200 minus 100 divided by 2, that is equal to 150 meter. So second case we are getting it as 150 meter. So first case I can take it as S1, second case I am taking it as S2. So what will be the total distance covered? Total distance covered will be S1 plus S2. So what is S1 here? 100 meter and S2 is 150 meter. 100 plus 150, we will get it as 250 meters. Okay, clear? Understood how we are doing this kind of numericals? Okay. So the next one is, a train starting from rest moves with a uniform acceleration of 5 meter per second square. Find its velocity when it has travelled a distance of 1 kilometer. So train is starting from rest. Tell me. Yes, initial velocity is equal to 0. Then next is given acceleration. How much it is? 5 meter per second square. Find its velocity. So final velocity we should find out when it has travelled a distance of 1 kilometer. So S is 1 kilometer, that is equal to 1000 meter in SI unit. So U, A, V, S. Which will be the formula relating all these things? V square minus U square equals 2AS. From there, V square minus 0 square equals 2 into 5 into 1000. So we will get it as V equals, V only we need to find out, right? So root of 2 into 5 into 1000. 2 5s are 10. So it is, okay. So we will get it as 100 meter per second. Okay. So understood all of you? In next class I will be coming with the topics which I covered as revision till now. that is about this equations of motion, graphical representation and the initial formulas of acceleration, velocity and displacement, everything. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.